today, basically what I'm going to talk about is how can you generally think about evaluations when it comes to AI applications, all the way from the offline setting to the online setting, kind of orchestrating the whole process and making sure that you're building something trustworthy that people can rely on. Again, just about me really quick, like what's my experience with the space? As Daniel mentioned, I got started in GenAI development back in 2021 before it was called GenAI. We were working on a lot of early prototypes, a lot of demos, but back then itself, we all started thinking very critically at Microsoft about like, what does a reliable test pipeline look like for these prototypes? And I later co-founded HoneyHive with my co-founder Mohawk in late 2022, basically around like taking some of these ideas that were brewing within Microsoft and other product teams at the time in 2021, 2022, and bring that methodology to the rest of the market through HoneyHive. And while I've been at HoneyHive, I've got to architect many evaluation systems for all kinds of AI applications, multi-agent systems on AutoGen, text-to-SQL apps, financial Q&A. Like, basically, I have seen the kind of like the breadth of the different use cases and the different approaches that people take for evaluation. So today, I think I want to start this talk just from like a very simple question, which I think every person, no matter whether they're technical or non-technical, ask about AI, which is, can I trust this thing that I'm using? Can I trust ChatGPT? Can I trust this text-to-SQL thing? And the second question, more for developers and for all of us who are building these applications, is how do we build that trust and guarantee it for our customers? And I'll make sure not to leave stuff high level and theoretical. I will give you guys an actual example of a system that you can build for like a complex application. So for answering the question of can I trust my application, I'm going to take it more generally from how was this done in the past? Like how did people in DevOps, MLOps think about like measuring trustworthiness? And we can basically try to first figure out like, okay, how many of those ideas can we bring to GenAI? And also figure out where the analogy sort of ends. And how do we measure performance in this new kind of domain, where something that's kind of unique to GenAI and could not be transferred over from the past. And then based on these insights that we generate around like, okay, what could an ideal evaluation system look like? We will go into setting up like, how can we use these insights to build an automating testing system, starting from the prototyping stage all the way to like the production stage with like live users. And I'll give you an example of that. So an obvious slide, but I do want to broadcast this very clearly. People don't trust AI today. Search engines lie to you. Customer support bots get Air Canada into trouble. Financial Q&A bot, can be not reliable. These kinds of like high value use cases are really like very critical use cases as well. And people cannot trust these applications once they watch it fail. Like it becomes very hard. You kind of have like at HoneyHive, we think about it as like the 4-error failure rule. Like if your application fails 4 times in quick succession, people stop trusting it. So like trust is very hard to rebuild. So before you put something in production, please think carefully about how reliable it is. Okay, so how do we make sure that our application is trustworthy, right? The concept that everyone talks about is evaluation. If we break down evaluation very clearly, there's 3 aspects that it's measuring. One, sort of on the positive scenario, is can I guarantee that my users will be happy when they use my application? In the middle, kind of like in the iteration workflow, is like if something goes wrong, can I quickly discover what went wrong and fix that thing? So enable rapid iteration. And then on sort of the negative scenario, on like the worst side, like can I stop like outlier negative scenarios from happening in the first place? And even if they do happen, can I catch them and stop them? So those are like the kind of the spectrum of evaluation and how it works. And yep. How is this done sort of typically? I think these are ideas probably most of you are familiar with from software and ML, which is to generally measure if it's going to do well in front of my live users. You come up with some kind of closed simulation of it, staging environment, acceptance testing environment, something like that. You test it over there. If you want to figure out what went wrong, you basically set up like close monitoring on different parts of it. If something goes wrong, you quickly measure, okay, this part failed, and that allows you the insight to like iterate quickly. And then if you want to stop something bad from happening, you basically keep testing your application throughout the life cycle of its development. And Also set up guardrails or exception handling sort of around things that you know will probably lead to some kind of negative extreme scenario in production. So this is just sort of how it's done. Making it concrete in software, the way it's measured how to do well is user acceptance testing, what went wrong, regression analysis, unit tests, and can I stop it from failing in the first place, end-to-end tests, exception handling. Classical ML has some similar analogies with offline batch eval, kind of explainability stuff, and then validation loss and live guardrails. And this is like basically like what the past has told us on how people in the past have thought about building reliable systems. Now at HoneyHive, we first think about evaluation as like each one of these different types of evaluations is basically taking some form of a system, which we call a configuration. You're running it against a set of inputs, which is like the data set, and then you have something on the other side measuring how your system's responding to the inputs, which is like evaluators. And what you'll notice about these different ways of evaluation is that unit tests, for example, are like very low depth, they work very fast. They're kind of supposed to run actively as you're iterating. So these are like very light style of evaluations, which are constant. Integration tests, they run more rarely. They're more higher in depth. They run more slowly, and they're kind of done before deployment. Offline batch eval, kind of similar to integration tests. Very deep kind of data set, which measures as much, maps as much from production as possible and runs very slowly. And this is just to like give you like the final green pass before going to production. Live guardrails, again, because these are like real-time user experience, they have to be super low latency, super fast, and they need to be something that is reliable on sort of a course level. And so yeah, these are the kind of different ways you can think about like the depth and the speed of like these different levels of evaluation. The reason I'm highlighting this is because this is what will transfer over to GenAI from these previous methodologies of evaluation. As you're changing your prompts, as you're changing your retrieval pipelines, you want to have like a bank of light evaluations, like unit tests, kind of hanging around the different components of your system. So as you're making those changes, you're constantly making sure nothing breaks. So unit tests, regression checks. The other is you want to run very heavy evaluations before you deploy. This is like just running a bunch of like really positive scenarios, really negative scenarios, getting a lot of human feedback before moving to production. So this is like offline batch evals, integration tests, and like a beta user group. And finally, in the kind of live user usage setting, you want fast guardrails. Something that works really fast, can catch something horrible that the model's about to do, and then stop it right there. So these three kind of methodologies transfer over. But that's where the analogy stops. Because the main problem is evaluators. How do you measure performance? Because like here on the board, I have like 3 summaries. So like the evaluation problem for GenAI actually first showed up in NLP with abstractive summarization, where people were trying to come up with different summaries for a particular document, and they couldn't figure out like, hey, what metric do I use to know even before putting this in front of my user that this is going to be a good summary? And what they realized was there's no fixed ground truth. It really depends on the user, what's considered good or bad. So F1, recall, eval loss, output regex, these kind of things don't work anymore because you don't have like an objective answer that the model is getting to. It kind of has now a much more wider canvas that it can operate within. And the other thing is we don't have the niceties of software where the thing just crashes if something goes wrong. Because now it's like, let's say, our summary has some like logical error or like some factual inconsistency. Your string handling is not going to know like, oh, there is a false statement in here. So you don't get exception handling. You don't have deterministic failure modes essentially anymore that you can kind of rely on. So this is like the biggest challenge in GenAI evaluation, which is in the positive scenario, it's very hard to say if something's going to go well because it's subjective. There's no fixed ground truth. There's non-determinism baked into the system itself. In the kind of middle scenario where you're trying to iterate and improve slightly, now the types of failure modes have expanded. The scope of the failure modes have expanded. Like GenAI is not just a model. It's like a combination of software and a model. So like your retrieval pipeline can fail and your generator could fail. And it's like very hard for a user to tell like, oh, was the context fetched that was incorrect, or did the model misinterpret the context that was fetched? So even kind of debugging the kind of failure that's happening is becoming very tricky. And in the more extreme scenario, it's very hard to stop something dangerous because these models are very intelligent. And so as they do a lot of intelligent things in production, you can't have a human standing behind each one of your users and like looking at what the model's about to do and be like, close your eyes, please. Or, those kind of things don't work. Like, for example, like I used to think this about Devin when it came out. I was like, yeah, like, I don't know, it might just crash prod. Like, and you won't know like if it's putting out a lot of PRs, which you want it to do. You want it to scale. Like, it's very hard to really kind of constantly stop it from doing something dangerous. And this is why most AI applications are still human in the loop. They're not like fully agentic and automated, because this kind of like extreme negative scenarios are very hard to avoid. So what's the common piece here? Like, let's try to find a practical solution right now, because OpenAI and Anthropic are not going to slow down, and people are going to keep shipping applications. Like, what can we do for evaluation? So as all the previous talks have already pointed out, human evaluation is still the main piece. We still have to rely on humans as much as possible, because humans are the only ones who can take the subjectivity into account properly. They are the ones who can review complex traces and reason critically and figure out what went wrong. And they're the ones who can actually talk to your users and intuit from them what are the subjective failure modes that you're seeing in production. So reliance on humans is still a very critical piece. And this is famously called the vibe check. You just get in the playground, you try running a bunch of different things, and then you vibe with them all, and you're like, you pass the vibe check, like, get in. Like, and we do think let's keep the pragmatism. Like, I get vibe check is like iffy and not reliable, but let's make it more productive. Let's make it more reliable. First thing you can do to make vibe check easy for people on your team is leverage very simple criteria. Don't have them think too hard. Have them use binary ratings, good or bad, simple scales, better or worse. And also, as much as possible, it's very hard to do this in practice, but it's worth the investment. Think of different ways of getting implicit feedback. What was the sentiment of the user's last message in the chat session? What was the things that they clicked on the screen when they were interacting with my application? This is very worth thinking about, because this will end up being a much more scalable way of getting human evaluation. And as folks have already said in talks before, like, be very, very selective over the samples that you expose to the people who are evaluating your application. Try to only highlight like very tricky regressions. Try to maximize the number of topics that you're hitting. Basically, don't try to have them go through everything one by one. Like, trying to just think intelligently about what kind of cases you want to have evaluated. And as I think every single application developer before me has said, codify heuristics. Humans are people will come up with intuitions based on playing with the model, like, oh, all this talks in this chat-like style. That's a heuristic. Track it, like, turn that into a rule. Like, is the model response starting with sure, let me help you with that? Is the model contain the response as an AI language model? This, I will tell you, is the highest bang for your buck in terms of evaluation that you can get, which is deeply intuit and introspect, like, with your users and with yourself, like, what are like some basic principles or techniques I can find, which I can turn into simple Python metrics and run over my logs to quickly figure out like the main failure modes. And these will be used in unit tests and can also be used in live guardrails. But you did not come to this talk to learn how to do things manually. This is not enough. At HoneyHive, we believe that if AGI is going to be this transformational 50% of GDP automated kind of a thing, it's got to be 6 sigma reliable. 6 sigma reliable means 3 failures per million runs. This is the standard that airplanes hold themselves to, oil and gas pipelines hold themselves to. These are super critical systems that you want to aspire towards achieving, because as AI becomes more cognitively capable and you give away more and more critical workflows to it, you really want that level of trust and reliability. It cannot just be like, hey, it felt good or it felt right. Like, that's not going to work, especially in production use cases. So using very basic statistics, this means that you want to validate against 800,000 examples before going to production. And if you look at Mechanical Turk, this will cost you $240,000 with humans, and it'll take you 8,000 hours to actually run this kind of deep evaluation, which will give you that reliability guarantee. And I mean, this is not scalable. Like, because we want to be running this evaluation before every production deployment. Like, every time we put anything new in front of the customer, we want this level of faith in it. So what's the alternative, right? Like, it can't be code because code cannot reason. So it has to be some kind of a model. What about GPT-4, right? GPT-4, if you look at it, it's actually strangely actually very similar to a human rater, like $30 to $120 for 1,000 ratings versus 300 for a human. So it's like less than half the price. Takes about an hour for 1,000 ratings compared to 10 hours for a human. So it's like 10 times faster than them. And then it has way more consistency compared to humans who they disagree a lot. So it's very tricky. Even with human eval, you have to do a lot of consensus. You also want to include a lot of different kind of users when you're like offline testing it. So with GPT, we could see some potential, right, for having this thing being our evaluator and giving us a signal before we go to production. And we have, with a bunch of customers enabled GPT as an evaluator, and we have noticed that the explanations that GPT generates when it's scoring things are very nuanced. Like, for example, here we ran context relevance over 2 chunk retrievals. And we saw in one case, the model gave a score of 3, and then it went really into depth on like, oh, something can be misconstrued in this context. It's missing key details around this part of the user's question. And like, it's giving you very, very high signal right now on what's wrong with your retrieval pipeline. And in the case of like 5, it can give you like a very well-reasoned kind of score on why it went well. So LLMs have the potential. It's there. And, Anthropic, RLAIF, they have made a very serious bet on this. They think AI can serve as a really good feedback mechanism for training. OpenAI's own super alignment team knows that when AGI does become much more intelligent than humans, we will have to rely on other AIs to align them. So they are going deeper and deeper and investing 50% of their GPUs in this direction. And famously, like the first paper which made LLMs as a judge a acceptable thing to say was the NLG eval paper. And they found a very high correlation between human ratings and GPT-4 ratings when they ran like basic criteria analysis. So I also want to give you a warning that even if you hire people on Mechanical Turk, we have found sometimes use ChatGPT. So the way we noticed it was we gave them some really complex tasks to annotate, and they finished it in a second. I was like, damn, like they must be really speed reading. But then we like took those inputs, we put it in ChatGPT. ChatGPT was like, same score. And I was like, fuck. Like these kind of things are happening. So GPT as a judge, like it or not, is the future we're heading into. And we do think that this kind of like AI as a judge system can scale. Like right now, does it meet our criteria of the Six Sigma reliability level that we want to get to? Not just yet. It's just 10x faster. It will still take 800 hours for GPT to review your logs. So you can't wait 800 hours before going to prod. It's consistent, but it's not a reliably deterministic system. Like everyone who wants good evaluations that we have talked to want their eval system to be as close to deterministic as possible. It can't just be like, I ask it for a rating on the same thing, and then on a bad day, it gives me a different rating. On a good day, it gives me a different rating. So we want the consistency to be as close to 100% as possible. And we have seen, like in the application side of LLMs, like people have tried to solve these problems by making their model tinier, training with a lot more data. But we still think the main problem, even if you solve speed, consistency, and cost, is bias. Models are very biased. Actually, a lot of these biases, when you pay attention to, comes from humans, and it's been trained on our data, so it kind of makes sense. So LLM evaluators, like the most famous biases are like order bias. It likes things that come earlier in the context versus later. Compassion fade. It likes responses that has more familiar terms in it to its training data compared to the terms that are not in its training data. So it automatically leans more in that direction. Egocentric bias, it likes responses that were generated by itself to responses generated by other models. And salience bias, it likes, nuanced, detailed, like edge case handling kind of answers instead of like simple answers like no. Like, it doesn't like those. And you might be asking yourself, like how bad could this be? I mean, like, sure, there's some bias, but it's kind of bad. Like, GPT-4 has really high egocentric bias. Like, it really likes its answers. Like, you put Claude in front of it, it's like, no. Like GPT is like way better. So using GPT-4 as a judge for evaluating Claude is a trap. Please be careful. And then you have, for example, Llama V2 has a very clear order bias. So it really likes, if you're comparing two responses, the first one is always better, or like more likely, 0.5 times more likely. Like, it's like, yeah, this one's better. So these biases exist, and it's really important to be aware of these if you're trying to use AI evaluators in your system, because we do want to mitigate these biases as much as possible to make our eval more reliable. So, okay, some of these biases were kind of in like a comparative setting. So you might argue, okay, let's get rid of order bias and the egocentric bias or something like that by just scoring individually, right? And then the question kind of naturally arises like, okay, how do you want to grade it? Do you want, I like it or I don't like it? Do you like, 1 to 5? And we ran this experiment and we found some really strange things. So I took a very simple task. I took MMLU. MMLU has clear ground truth. So it's kind of a more constrained setting so we can evaluate the evaluator more clearly. And what we found was if you use the Likert scale, it gets false cases. If you use binary, it gets true cases. It's the same model, guys. Like, it's just a different grading scale, and it completely changes its behavior in terms of how it's able to score more accurately or not. And the point that we're trying to make with this slide is like, really think very hard about your automated evaluators before you put them in place. You need to think about biases for extremes, for example. Like when we did Likert, it didn't use 2 and 4 at all. And then salience bias, it still prefers long responses. Like when I reviewed the logs for why it failed some responses, it's like, yeah, the answer is correct, but it didn't go into depth. Fail. I was like, what? So salience bias is a real issue with these models too. And ego bias is always still there, especially with GPT as an evaluator and so forth. So some approaches, obviously, the naive idea is let's just, few shot it, counter its bias a little bit, give it short answers and make it realize that those could be good too. And give it different models responses and make it realize those could be good as well. And we do think this is a point where this is a good kind of hacky solution for now that you can try, which is okay, rely on human feedback still. Human feedback is the way to go. AI evaluators, as I just showed you, have a lot of unresearched quirks that we haven't seen a lot of papers written on, but we feel should be critically studied. So what you can do is figure out the criteria that you basically want a human to evaluate with and give those same criteria to AI. Have humans and AI evaluate the same kind of logs, and over time tweak your AI model's prompt or maybe train the model so that it gives very, very similar scores to your human evaluator. So in this way, what you can do is essentially wherever, by default, use your aligned AI evaluator. And whenever that AI evaluator is giving scores towards the extremes or something uncertain, if it's very inconsistent, then show it to a human, which is the AI evaluator is really confused, it's giving wrong answers, its explanations aren't correct. And then that's one way in which you can intelligently sample what responses for a human to grade. And we found that the binary scale generally is more reliable than Likert scales and just few shot it really, really well. Try to find examples where the AI and humans have very different scores for the same responses, and try to use those to few shot the evaluator to get it more aligned. And please invest in this very early. You really want to automate your testing as much as possible. You don't want to leave it in the vibe check for very long because it's going to hamper you in so many ways. It'll be very hard for you to switch models reliably when new ones come out because you don't have the right eval harnesses set up. And then your competitor startup starts with the other model and quickly surpasses you or whatever. and so on and so forth. Like there's many, many advantages to testing. I mean, software, ML, everyone knows this. Same thing holds in GenAI. And so just make sure that you invest in aligned evaluators as early as possible. And in this vein, HoneyHive has been training our own evaluator models. We recognize this problem because we realized to reach that Six Sigma scale, yes, we will do the fine tuning to get smaller models, but we'll also make sure that the way we train these models is not like the way general models are used, but these models are more specialized towards providing accurate ratings on a calibrated scale with training data which includes scores from all categories. And so the model is not like super biased in one direction or another. And so we've created two models, one for the fast live guardrail setting, which can run really quickly, super fast, low latency, and just tells you like roughly if it's very bad or if it's very good. And then a much larger evaluator, which is more meant to serve as a base for the aligning AI evaluator and can be fine-tuned over your own kind of like grading data and then brought towards automating more of your human feedback. And this can be used in an offline setting for your batch tests before you go to production. In our studies, we found that it outperforms GPT-4 right now on correlation to human feedback. Its cost is 2 orders of magnitude low. It's 100 times faster. We haven't released it yet because we want to do more and more debiasing. We don't want to just release a model which is not completely unbiased or close to it as possible. So, yep, that's the current idea we have in the direction that we think at least the ecosystem generally needs to go in of like finding scalable evaluators, because that's the only way like the AGI vision might actually happen. So let's zoom out now. That was a lot. I went really into depth on how we can measure performance in GenAI. But like, we at HoneyHive, we want to build practical systems, so we're not going to leave you at theory. And let's think through basically how can you actually orchestrate this entire system throughout your application development process from beginning to end in order to make sure your application is reliable by design or it's trustworthy. So this is a lot happening on this slide, but the basic problem that most people have with setting up evaluations is twofold. They find it very hard to collect data sets quickly, which are very expansive and cover a lot of cases. The other issue they have is like they don't know exactly what to measure, how to measure, and so they're kind of left lost in like, how do I set up my final harness? The real answer is you want to be constantly on the lookout for good examples and good heuristics throughout your development process. Like keep logging what's going on, what everyone's doing in your team. So what I mean by that is, let's say you started in the playground. What are the kind of examples you're giving to throw the model off to like figure out like if this thing's gonna fail? Track those things. Those are good examples that you can use later on. So these we kind of consider like simple salient examples. And in that playground flow, when you were vibe checking, you're gonna come up with like weird things like, oh, it's not following my data format. That's a good assertion. It's not following my guidelines that I explicitly gave it. That's a good assertion. Track those things. Track which guidelines it's like constantly failing on. Track like what kind of data format errors it's having. And keep adding that to your bank as you're in the prototyping phase. Next, when you put it in front of some users who are basically outside your development team, what you want to do is monitor every single thing they're doing in terms of what are the cases that they're throwing at your application where it's getting very confused and where the user is getting very unhappy. That's kind of like the negative scenarios that you can start tracking. Similarly, for happy scenarios where user is going to come to you and be like, wow, you built such an amazing application. That's good. That's the happy scenario. Keep that tracked very clearly. You don't want you to regress on that over time. And so this way, you can basically just assemble those simple like evaluation sets that can be further expanded in batch. And main thing is, please like try to communicate very deeply with your users and ask them to explain their intuitions on why they didn't like what they had, which is like, oh, I felt it was too verbose. I felt that it beat around the bush too much. I felt that in the case of agents, it started looping whenever I ask it to this kind of a thing. These are all, again, really good evaluators that you can measure and keep going with later on. And the same kind of analogy. So now actually, before you go to production, from your beta users, figure out what were the extreme negative scenarios and make sure to configure guardrails before going to production. We still don't know what the model can do. It's non-deterministic. So make sure to figure out like what are like the most harmful scenarios that beta users discovered themselves and configure guardrails for those beforehand and keep it right there. Again, as I mentioned earlier, also before you go into production, set up that implicit feedback signals from the UI. And once that's all in place where the negative scenarios are captured, the implicit feedback signal is coming in, then you should go to production and then keep augmenting your data set as you go up. But this is just one pass. This is just in terms of how to collect your evaluators, how to start assembling a data set. You can play around with synthetic data generation to kind of extra augment your data set. There's still not a lot of good research on like what are optimal synthetic data gen prompts, but these are things that we're also figuring out. And then with evaluators, you can also figure out like as much as possible, like as Kenny from Coda mentioned, like you want to rely on like Python type evaluators, like deterministic ones as much as you can, than like LLM based because of like the issues that we highlighted earlier. But still, they still do serve as a good signal if you just in the extreme case. Now, that slide, okay, helped you kind of figure out, okay, this is how I can figure out the test cases, this is how I can figure out the evaluators. This is how you should orchestrate your application development process in order to ensure reliability by design, which is, I mean, these are all practices that came from software and ML, where when you're in the prototype phase, have a PM as much as possible, do the vibe checks, someone who's more closer to the user and has more empathy, and get them to give the vibe check pass. From there, move into the iteration phase. Now, we've had a lot of customers complain around like, you know, like I feel very unconfident making changes to my prompts. I don't feel certain, like, you know, changing my retrieval pipeline. For that, you need to set up unit tests. This is a problem that software engineers have dealt with before. And your unit tests need to be very light, have very simple evaluators, have like basic tricky test cases that you can run against. Again, very similar to software. And there you're basically asking yourself, are my simple heuristics kind of passing? So as you keep iterating and pushing commits, keep running your unit tests. When you're certain and good, feeling good about your application, send it through the regression check pass. The regression check pass basically takes the happy, unhappy scenarios from earlier and uses the large, fine-grained AI to give like detailed error descriptions on this pipeline is missing on these things, this pipeline is doing well on those things. And have a PM or a domain expert also review that and basically give you that subjective pass on like, okay, cool, let's send it. This is better than what we had before. At the application stage, integration tests, I think it's like a similar idea as unit tests, just over the entire application. And now batch evaluation pass. Here, I did not get to talk as much about safety and red teaming because I had to constrain this talk just on application performance and reliability. But you also do, it's very important to do the kind of safety checks and on top of the quality checks. And this has to be a much more in-depth, deep evaluation, which covers a lot of different scenarios. And once those pass with the domain expert and the large AI who's automating their feedback over time, you show it to the user, and then you have your simple guardrails there. The basic idea behind this orchestration, if you had to just summarize it in your mind, is if your system changes slowly, then you need it to be more reliable, which means you need to have a deeper and slower evaluation of it. So as you get closer to the user, your system changes less frequently, so the evaluation need to go deeper, 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 deeper. But earlier, when you're iterating very quickly, you want your evaluations to be light, but measuring like small changes, so you know things don't break at integration testing or batch evaluation. And I promised you a practical example. Here it is. This is one of our customers, Multion. They're building a very, very open-ended web browser agent, which can do any kind of web task. And you can imagine reliability is quite a pain point for them. And we basically help them orchestrate an entire evaluation system from their iteration phase to the online phase. The way it works is very simple. On the unit testing front, for every one of their prompts, they just did simple response format and guideline checks. That's their unit tests. For integration tests, they have looping validators, action validators, safety validators, just kind of basically making sure that the agent's not getting confused a lot and it's not doing something dramatically bad. And this is also a very simple kind of test that they do. Finally, basically, whenever they want to replace something in production, they do a human review. So notice that these two are automated. Only when they're kind of comparing against some system that they already have, then they invite human reviewers and they look through screenshots and so forth and have like multimodal evaluation pipelines which go through and validate the action space. And finally, they have a very, very deep offline batch eval that they've assembled through a lot of inputs that they've seen where users have been unhappy and happy. And this is a much more slower evaluation, but this is also something that they're trying to automate fully as much over time. And the live guardrail setting is as simple as just make sure it's not doing anything inappropriate. Simple moderation filters is what they have right now, but it's something that we're expanding over time. So there you go. We've kind of covered a lot of ground. We've kind of talked through on, can you trust your AI application? The way to think about it is develop a very broad test bank, develop a broad set of heuristics from human feedback, and try to measure that constantly at every part of your application process. And still rely on human feedback, but know that within a year, human as a eval is probably going to go out of favor. So keep working on aligned AI evaluators, which are basically trying to mimic what your humans are doing. And then how do you basically build this trust, and how do you build a trustworthy application? As I said earlier, if you're putting something in production, try to do slow, fine-grained evaluations which go very deep. And then that's in the offline setting. In the online setting, in front of users, try to keep simple, coarse-grained, really quick-acting guardrails. And again, rehashing the scalable evaluator point, please work on this because this will allow you to like A/B test models. It'll allow you to A/B test retrieval strategies. It'll allow you to A/B test like generator strategies. So this is how basically by doing really broad experiments, doing a lot of validation, this is just generally speaking how you will actually build a reliable, trustworthy application. So that's our goal at HoneyHive. We're going to help the ecosystem build these applications, Six Sigma reliable. We'll build evaluation systems that are going to be fast, cheap, and effective. And everything that we've talked about today, people have set up in HoneyHive, CI/CD tests, regression analyses, live guardrails, so on and so forth. Thank you.